Previously, we looked at kinematics and specifically displacement, and when we plotted displacement versus time, from that graph we were able to figure out velocity. Well, when we plot velocity versus time, so we have an object, it could be a ball, something moving at a certain velocity meters per second. We have the velocity plotted on the y-axis and time on the x-axis. We see a straight line. Now, if we use the same procedure we did last time, and if I find a good meeting point, let's say this one seems to be a good point right here. And if I calculate slope, which is rise over run, it is going to be, my rise is going to be change in velocity, and my run, the x-axis, is going to be change in time. And so, if I do that, my change in velocity is 100 minus 0. My change in time, 50 minus 0. So if I look at this change then, 100 meters per second over 50 seconds, what that gives us is 20 meters per second squared. And that is the acceleration, or change in velocity. You can notice an acceleration in many places. It could be in a car as it speeds up. That's a positive acceleration, making it go faster. In a car, when you apply the brakes and you slow down, that's a negative acceleration, or an acceleration going in the opposite direction that you're moving in. So now we have a new formula, and that is for acceleration. Acceleration is a vector, and that is change in velocity over change in time. So if we do an example, if we have a car, and the car is initially moving at 50 kilometers an hour, and then it slows down to 30 kilometers an hour by applying the brakes, and it does so over a time of 3 seconds. And then we can calculate our acceleration by doing change in velocity over change in time. Remember, change is always v final minus v initial. So v final minus v initial over our change in time will simply be 3 seconds. So our final velocity is 30 kilometers an hour minus 50 kilometers an hour over 3 seconds. Now we run into a problem though. You look at the top, we have kilometers per hour, so the unit of time is hour, and the bottom is seconds. So this provides, this means that we actually have to move things around a bit. Kilometers an hour and seconds don't work. So whenever you have mixed units, what you want to do is change it into the same unit, and if you're really not sure, the safest way is always SI units, which means meters and seconds. So what I will do is convert the kilometers an hour into meters per second. The fastest step is first take my change in velocity, which is 30 minus 50. Kilometers an hour, so that gives me negative 20 kilometers an hour. And next I want to convert that into meters per second. So if I take negative 20 kilometers an hour times, now convert hours into seconds, so I put 1 hour on top, and in 1 hour there are 3,600 seconds. And then I want to convert kilometers into meters, so 1 kilometer on the bottom and 1,000 meters on top. This lets me cancel out units. Let me check. The hours cancel out with hours, and kilometers, cancels out with kilometers, and left with meters on top, seconds on the bottom. Perfect. So that gives me 5.556, negative 5.556 meters per second. So there's my change in velocity. Acceleration, once again, is change in velocity over change in time. So my change in velocity is negative 5.556 meters per second over a time of 3 seconds. And that is 1.85, negative 1.85 meters per second squared, which are the units for acceleration. It's always distance over time squared. It could be meters per hour squared or kilometers per hour squared. Those aren't very conventional units. 99% of the time for acceleration you're going to see meters per second squared, so that's something you're always going to try to do. Taking a look at this example, if a bike starts at 9 meters per second and accelerates at 2.5 meters per second squared for 5 seconds, what will its final velocity be? So we'll start with the acceleration formula. Acceleration is change in velocity over change in time, and I'll rewrite this as v final minus v initial over change in time. Notice there is no direction, so we don't really have to worry about the direction component of the acceleration. We're just calculating magnitude. But if the velocity did include a direction, north, south, and so on, as velocities do have, then you must include that in your answer. So, to find final velocity, I need to do some algebra and rearrange this. So I'm going to multiply both sides by change in time, and that gives me and then I'm going to flip things around and solve for VF, and VF will be which happens to be a pretty common formula that you see on your formula sheet. So to find final velocity, we're going to use initial velocity plus acceleration times time. My final velocity will be my initial velocity, 9 meters per second, plus 2.5 meters per second squared times a time of 5 seconds. Meters per second plus, notice how one of these seconds cancels out with a second squared, and so get 12.5 meters per second. My units are working out, which is great, and then my final answer is 21.5 meters per second.